Hi guys, on this video I'll be talking about the medium transmission line. A medium transmission line has a length of about 80 kilometers to 240 kilometers. The ABCD parameters are normally calculated using three methods. There's a nominal pi method, and there's a nominal T method, as well as the end condenser method. On this video I'll be speaking about the pi method, and I will be doing other methods on a separate video. So a pi method is having a capacitor that is divided and lumped in either end, either sending end side and the receiving end side, with the line in between. So let me write that equivalent circuit so that you can see it. Resistor, inductor, sending end, receiving end load. Okay, so this will be the sending end, capacitor lumped closer to the sending end, and the other one lumped, the other half is lumped on the close to the receiving end. So here is a receiving end voltage. So we're naming this capacitor C1, we're naming this one C2, this will be RL, and this will be XO. Okay, this is our Z. So this will be our Z line. Okay, current IS is coming in this direction. IS splits here. One goes to capacitor C2 and the other one goes straight to the line. So name this current that comes in here IC2, and we'll name this current IL. Okay, so IL comes and splits here. One current goes through C1, we'll call this current IC1. One current goes to the receiving end, we'll call this one IR. Okay, so on the ABCD method we are looking into the equations of VS and IS with coefficients of these constants ABCD. So it will be looking something like this. A will be multiplied by VR plus B multiplied by IR. So this will be the equation for VS. So now by looking at this equation, we need to calculate A and B using the medium transmission line equivalent circuit. So IS looks like this. So it's going to be C VR plus D IR. So writing this in the matrix form will be VS IS equals to A B C D. Okay, so VR IR. Right, we want to be able to calculate A B C D and then easily find VS and IS. So now we need to know, in terms of this diagram here, what is our VS. We can see our VS is sitting across this capacitor, and then we have a voltage drop across the line, and then we have the receiving end voltage. So it's going to be the receiving end voltage plus the voltage drop will be equal to the sending end. So VS, my marker is not writing here now. VS equals to VR plus the voltage drop is this impedance times its line current. So it's going to be IL times ZL. So that will be our V sending and voltage. But now we want to know what is our IR. Our IR, coming to this, our IL, our IL, when we come to this equivalent circuit, we can see our IL splits here. One goes across the capacitor C1, the one goes to the receiving end. So it's the sum of these two. So IL is equal to IR plus IC1. Okay, what is IC1? IC1, okay, on this equation, the shunt capacitance is represented as the admittance. Half of the admittance on the other side. So it's Y over 2 here and Y over 2 here. So these capacitance are represented in the admittance form. So now this current goes through here will be VR times the admittance. So IC1 is equal to Y over 2 VR. So we take that and substitute in this equation. We have IL equals to IR plus Y over 2 VR. Okay, so we find this equation. Let's call this equation 1. So now substituting this into this equation 0, let's call this one equation 0. Substituting this to the equation 0 in the place of IL, we're going to have VS. So all of this will be multiplied by Z line. So let's keep VR here plus IR times Z line. So it's going to be IR ZL plus this combination here, which is Y over 2 VR times ZL. Okay, so that's what we are having right now. And now we need to write this equation in terms of ABC, which is the coefficients of VR and the coefficient of IR. Let's go ahead. We have VR here, we have VR here. So meaning that there's a common factor. We can take VR out. We'll be left with 1. And what we're going to be left with here is Y over 2 Z line multiplied by VR. Okay, then we are left with this one. So this is going to be plus ZL times IR. Okay, so if you look at this equation now, it resembles this equation. So we have this point here, which is the coefficient of VR, and we have this point here, which is the coefficient of IR. So meaning that we found A, which is A will be equals to 1 plus Y ZL divided by 2, and we find also B. So B is equal to ZL. Okay, impedance of the line, that's B. So now we want to calculate C and D. We need to derive C and D, find out how to get to that one. So IS is the current that comes in. If you see the equation, it's current that comes in, and it splits at capacitor 2 and the line. So that means IS is equal to IC2 plus IL. Okay, do you know what IC2? IC2 voltage is sitting across this capacitor is VS. So we multiply this admittance with the VS and we get IC2. So it's going to be VS times Y over 2. we get this current. So substitute this current here in the place of IC2. So it's going to be Vs y over 2 plus, we have IL. IL, we did calculate it. It's this one, equation 1. So equation 1, substitute that equation here. It's going to be IR plus y over 2 VR. Okay, so we want to write IS in terms of C and D. C and D consist VR, IR. We don't want to see VS. So now we can substitute VS because we do have VS equation. Let's take this one, this equation, and multiply each term by y over 2 on that equation. Okay, so we have VR times y over 2 plus IR z line times y over all over 2. Okay, so we have this one that will be plus, then it's also having y over 2, so it's going to be y squared VRZL divided by 4, because it's 2 times 2, that will be 4. So now we're left now with this remaining terms, which is going to be IR plus this combination y over 2 VR. Okay, so we can see that VR y over 2 is the same as VR y over 2. So this one is going to be this plus this. That will give, this will give VR y. Okay, because half plus half is equal to 1. Okay, now we left with IR Z y divided by 2 plus y squared VR ZL divided by 4. Okay, so now we have to write this equation in this form, where we say we have a coefficient of VR, we have a coefficient of IR. Let's go ahead and do that. So we see we have VR common on this term, we have VR common there, so we can take, we see there's also y and there's also y, so we can take both of these out and say y into 1, okay, plus whatever is remaining here. So now it will be y z line divided by 4 into, so we put our VR here. So if you multiply out this thing, it will give us these two terms, okay, because it's going to be VR times 1 times y, that will be VR, and then now VR times yz line over 4 times y is going to be y squared. So it will give you, it will give us this. So now we'll be left with this term here. So this term is z y over 2. Okay, there is a term that we left behind on the top here, which is this IR. So this one is plus IR. Okay, it's plus IR. This IR should be included there. So now we have a common IR. We have a common IR here. So we can say 1, taking IR out, plus Z y over 2 into IR. Okay, so now we've managed to put this equation in this form of an ABCD parameter breakdown. So now we are able to, we can safely say now we have the coefficient of VR and the coefficient of IR. What is the coefficient of VR? it will be C equal to Y into 1 plus YZL divided by 4. Okay, and then we have what? We have D, which is D equals to 1 plus ZY over 2. Okay, so now instead of ABCD, we can go ahead and substitute C in the place of C. We can go and substitute D in the place of D. We can substitute B in the place of B. We can substitute A in the place of A. So now we safely establish the ABCD method. So guys, please like the video, subscribe, and also share with friends. This information is very important when you're studying medium transmission line. Thank you.